some other work, and he will likely to join after some time.
Okay,
He has permitted me to continue, sir.
You can start.
Okay, sir. Good morning to everyone. Respected CC sir, respected CST sir, and respected my senior officers, colleague officers, and my dear friends, ladies and gentlemen. As you know that today I am taking the webinar on 6 Quad and OFC maintenance and payload rectification. So I will be giving about the table and only restrict to testing part used and maintenance part of the OFC. These I'll be.
Voice is not clear, please.
Sir, my speech is okay, sir. To audible to everyone.
Now it is okay.
Okay, sir. Thank you, sir. So, as you know, the quad cable is being used in railways, and in Indian railways, different types of telecom network exist, and it plays a vital role for providing clear and distinct voice and data service. Various type of telecommunication cables with RDSO are used depending upon the requirement of the telecom and safety related signaling circuits, which are under utilization for functioning of the administrative and train operation activities. And in administrative purpose, telephone exchanges, RailNet, UTS, PRS, voice, MMIS, IRPSM, other applications, the administrative purpose, the cables are being used. And similarly for train operation, various safety circuits like block, LC gate, IB, BPSC, EC, and train traffic control communications, and apart from that, all other type of networks being used in railways. So different cables are being utilized. Just to give an idea about different types of cables, it has been bifurcated into two types. One is indoor cables and outdoor underground cables. In indoor cables, unarmed and paired cables are being used. In the pair also, screened, unscreened cables are being used. In screened cables, special cables, coaxial cables, which we are not using at the moment, only data cables are being used extensively. In unscreened cable, PVC switchboard cables are being used. In underground outdoor cables, PHF armored and screened coaxial cable, which we are not using at the moment, and OFC cable. In PHF armored and screened cable, paired 10, 20, 50 and 100 pairs are being used. And another cable which is extensively used are quad cable, 4 or 6 quad. These quad cables are being used for signaling circuits like block, BPSC, IB and TAWS. In telecom circuits such as control, LC gate communication and EC sockets, that is 4 quad or 6 quad cables are being used. The cables which are being used are RDSO spec, IRS TC30, 2005 version 2 for 0.9 mm dia conductor. And another one is RDSO SPN TC 72 oblique 07 for 1.4 mm dia conductor, which is used for the longer block sections. So actually, most of our South Central Railway, the control is being used mostly through OFC, and quad cable is being used only for block and LC gate communication, IB phone and EC communication. So the majority of the quad cable is being restricted only for block, EC, LC and IB phones. The general specification of 6 quad cable is loop resistance will be 56 ohms per loop kilometers, transmission loss of 0.63 dB per loop kilometer unloaded and 0.25 dB per loop kilometer loaded. Whereas in our South Central Railway presently there is no loaded cables, but it is for the academic interest, we should know loaded will have a transmission loss of 0.25 dB. The impedance 470 ohms unloaded, 1120 ohms loaded. Insulation resistance shall be more than 100 ohms, 100 mega ohms per kilometer with 100 volts megar. Conductor dia nominally is 0.9 mm and thickness of the PVC outer sheath will be 2 mm. Thickness of GI armor tape will be 0.8 mm. Thickness of PVC intermediate sheath is 1 mm. Thickness of inner PVC sheath is 2 mm. Thickness of aluminum armor tape will be 0.2 mm plus or minus 10%. Aluminum wire used for the screening purpose is 36 or 12 numbers. Mutual capacitance of the pair should be 50 picofarad per kilometer. Generally, in most of our South Central Railway, now new works have come up for the RE, and the effect of RE will be so many precautions have to be taken. So these are all the few, these are all the points which are effect of railway electrification on telecom circuits. In the system of electric traction adopted by the Indian Railway, the catenary wire is fed with the 25 kV, 50 cycles and single phase. The rails are being employed as a return conductor. Such an arrangement, while resulting in several advantages in respect of the power transmission and traction engineers, and produces certain undesirable effect on communication circuits in the neighborhood of the track, rendering them unsafe and unworkable. The mechanism of induction from the 25 kV AC traction system is due to electrostatic coupling and electromagnetic coupling. So electrostatic capacitive coupling, with this the characteristic maintenance at 25 kV, an electric field is created in the vicinity of the track. An electric conductor such as communication wire insulated from earth and situated within the field will get charged to a certain potential with a reference to the earth due to capacitance coupling. The magnitude of this potential depends upon the voltage of the catenary and distance. As far as electromagnetic induction, the current flows in the catenary returns to the feeding point via the rails. The rails are not specifically insulated from the earth, therefore provides an alternate path for the current. Some portion of this current penetrates deeply into the earth to find a path in other rails, cable sheets, metal pipes, and similar conductor parallel to the tracks. The current in the catenary is a source of alternate magnetic field. This field cuts any conductor parallel to the track and induce EMF in the conductor. So this has been, the screening factor K is being calculated based on voltage induced in the conductor in presence of metallic sheet over voltage induced in conductor in the absence of metallic sheet. The reduction in the induction voltage that is affected by the various conductor parallel to the catenary system, each such conductor has a screening factor. The screening factor is normally less than unity. Generally, this value is as low as possible. The cable to be laid along the track should have an aluminum sheath and sheet tape armored so as to have a screening factor less than 0.1. There are some recommendations made by ITU for telecom for this RE precautions. Regarding electrostatic induction, the critical figure recommended by the ITUT is 15 milliamperes current. During the normal functioning of the power lines or electric traction system, the longitudinal induced voltage in the telecommunication circuit should not exceed 60 volts. During the abnormal functioning of the traction power line, the longitudinal induced voltage shall not exceed more than 150 volts. During traction power line short circuits conditions, the induced should not exceed more than 430 volts RMS. As regards interference to the speech transmission, the sophrometric voltage in the communication circuit should not exceed 2 millivolts. Further, isolation by way of sectionalization all the communication circuits to break the metallic continuity of the conductor to prevent cumulative building up of the induced voltage with the introduction of the isolation transformer at every 17 kilometers on long distance communication network. As far as in our South Central Railway is concerned, this situation, because the block sections are every 10 to 15 kilometers, the 17 kilometers length of sectionalization is not arising in our South Central Railway. If at all it is arising, we have to sectionalize by isolation transformer. In cable length increasing, as cable length increases, this voltage will also increase proportionately. If this longitudinal induced voltage exceeds 150 volts AC, the safety of the working personnel and equipment becomes hazardous as per the recommendation of ITUT. Provision of earthing and SPDs for all telecom equipments as per RDSO guidelines is to be mandatorily be utilized. Use of aluminum sheath or screening cable having good screening factor of 0.1 should be ensured. And power crossing 11 kV and above. So there are the chances of power line crossing across our tracks. So some precautions to be taken while carrying out these works in quad cable laid locations. Power and telecom cable should have a shortest length of parallelism. When high voltage power cable 11 kVA and above has a parallelism exceeding 0.8 kilometers, approximate safety measures has to be taken. Those are whenever laying a new telecom cable across the parallel to the existing 11 kVA and above power crossing, PTCC, that is Power Telecom Coordination Committee approval is a mandatory. As per the PTCC guidelines, the protection device such protection device shall be provided. It is advisable to take a telecom cable with a maximum horizontal clearance as far as practicable, but not less than 0.6 meters, so that the intensity of the induced interferences can be minimized. Absence of sheath continuity and armor continuity in telecom cable and its improper earthing in the vicinity of power cable will result AC induction and consequent losses in the telecom circuits. When the power parallelism is more than 0.8 kilometers, the cable route should be referred to PTCC for recommendation of the protection measures. In case of crossing, care should be taken to see that the telecom cable crosses the right angle and at a vertical clearance, preferably 0.6 meters, but not less than 0.3 meters at any given point. When the specific clearance cannot be maintained, it is preferably to lay the telecom cable through cement concrete pipes and seal the mouth of the both ends. In the vicinity of the switching stations, the cable shall be laid at least 1 meter away from the metallic body of the station, which is fixed in a ground, and at least 5 meters away from the station earthing. The distance of 5 meters can be reduced to 1 meter provided the cable are laid in a concrete pipe or a duct. Precautions to be taken for protection of the equipment in 25 kVA traction area. Crossing of track, if any, should be negotiated by underground cable running at a right angle to the track as far as practicable. Special protective measures, provision of GD tubes, gas discharge tubes, fuses, and earthing, etc., are required to be taken for telecommunication lines entering equipment rooms and OFC huts. Precautions to be taken by staff by using insulated tools, use rubber gloves and rubber mats. Before cutting the armor, this is very important, before cutting the armor or sheath of the cable, an electrical connectivity is to be established between the two ends of the cable through an external wire. This can be done by using crocodile clips in our regular practice. So as far as maintenance of the quad cable, different tests have been conducted for the cables. Testing before laying of the cable, testing after laying of the cable, fault localization of a localization test, testing of cable before commissioning of BPSC, and routine tests. First one is testing before cable. Any manufacturer, when he supplies, the cable has to be tested and ensure that the cable supplied is sealed on both sides. Check for any physical or mechanical damages due to transportation or because of the manufacturing defects. And continuity and insulation tests to be carried out on all the supplied cables. Test after completion of the cable laying. All the maintainer has to carry out minimum these two tests after laying of the cable, that is continuity test by using multimeter and insulation test by Megger. Testing of cable before commissioning. The following test results are to be checked before laying of the cable. That is conduction test 56 ohms per loop kilometer, insulation resistance more than 10 mega ohms, transmission loss test at 2 kilohertz on 100 ohms. Transmission loss will be 1.2 dB per kilometer and it shall not be more than 30 dB for full length section. Near end crosstalk at 155 kilohertz should be better than minus 55 dB. Far end crosstalk at 155 kilohertz should be more than minus 55 dB. Sophometric noise test should not be more than 2 millivolts. Continuity of armor should be ensured, and earth resistance at armor less than 1 ohm. And it should be ensured that position of the one cord in the quad cable is first pair should be A and B, and second pair should be C and D. Each quad is bounded by respective quad color binder. All these days, until last year, we have been conducting this conductance test, transmission test monthly, crosstalk and sophiometric test quarterly, and insulation test yearly. As per the new recommendations, as per the new recommendation of the Telecom Manual 2021, the routine tests have been revised. Underground cable shall be tested once in every year for continuity, transmission loss, crosstalk, loop resistance, armor continuity, insulation resistance, and tracing and updation of the cable route diagrams as and results of the test shall be submitted to DST or AST sectional officer. This is the new guidelines given in the new telecom manual. This can be planned during the joint measuring program of the division of respective section, or otherwise it should be planned by taking a proper block at their respective sections. The acceptance tests of 6 quad cable. So as already I repeated, to measure the loop resistance of the pair and resistance of each conductor measurement using multimeter. So we have to measure the resistance of the limb 1, conductor 1.
Okay.
Sir? Sir. I hope I'll continue. The measurement of the resistance of limb 1, measurement of resistance limb 2, and measurement of the resistance of limb 1 and limb 2. This has been conducted by using multimeter, connecting one at a conductor, and the other end a loop will be made to the armor, and the resistance value will be taken. Similarly, for the conductor 2 also will be taken a loop resistance, and third one is between the conductor, loop resistance will be measured. So second one is transmission loss test. This test is to measure the transmission loss of the signal in an underground cable. The transmission loss that occurs in the cable can be measured and the level of the speech will be recorded.
Working yeah, my
somebody has to mute, I think. Transmission measuring set, it is TMS kit. It generally been called in our day-to-day usage. The meter is basically divided into two sections. One is oscillator and the other one is level meter. The oscillator section consists of frequency selector. By using the frequency of the test tone can be selected. The power level of the oscillator is selected as per the requirement with the help of a power sectors, and the same can be fine-tuned with the help of a trans-level pot meter. The power level of the test tone selected in our regular basis is 0 dB. So this is the EMS kit.
Clarity ga చెప్పలేకపోతున్నారు. చేంజ్ చేసి రిపోర్ట్ పెట్టండి చూద్దాం అంటారు అంతే. ఆయనకి
Ravi Verma garu. Ravi Verma, can you hear? Any doubts? The TMS kit is generally divided of two sections. One is oscillator section, another is a power level measuring unit that I have indicated in the photo. So here the frequency can be selected to this knob, frequency knob, and if any level to be adjusted, 0 dB level is been adjusted in the knob. The other end, this can be measured at the screen by selecting, because it is most of our cables are unloaded, it will be selected on 600 impedance. So this is a schematic diagram how connectivity between the two stations. The TMS kit is connected at the station A and station B, and the oscillator is at station A. Oscillator output is been connected to the limb 1 and limb 2, and the other end, the another end of the conductor is been connected to the input of the level meter. So these are the test recording registers. Here, each pair conductor 1 and 2 to be recorded for the conduction test, as well as for the transmission loss at 800 Hertz, 0.28 dB per kilometer for loaded and 0.8 dB per kilometer for unloaded. So as far as our railway is concerned, only unloaded to be tested, because it is none of our cables are being loaded. Crosstalk test. Here, the signal of one pair of the cable produced unwanted signal in the other pair due to electrostatic and electromagnetic induction effect. It is nothing but these unwanted signal are called crosstalk. The first pair is called disturbing pair. The other pair is called disturbed pair. The instrument used in crosstalk measuring set, the crosstalk is of two types. That is near end crosstalk, that is called next. Far end crosstalk, fixed. The typical, the picture of the equipment of crosstalk measuring set is been shown here. This is almost like a TMS kit only. The main difference in this is only one power line level, that is 0 dB, unlike TMS kit, which is more number of power level selector will be there. In near end crosstalk, the tone is set in one pair, and the level is, noise level is measured in second adjacent pair. So that is both are in this same place. Means if station A is set a tone and the tone in this adjacent pair is been selected in the same station. That is why it is called near end crosstalk. So similarly, this test has to be conducted by feeding tone in one pair and taking the level in the adjacent pair of the quad. Similarly, from quad to quad also to be tested. This is PS next, is power sum next, means it has to tested for each conductor to each pair to the with adjacent pair. Similarly to the other pairs of the other quad, adjacent quads. So the crosstalk that is measured at the end of the crosstalk that is measured at the end from where the signal is fed is called as near end crosstalk. For this test for this test, one crosstalk meter is required. That is at the station A, for example, from the feeding end, we can measure at the end of the cable path, we have to select a characteristic impedance, fix a characteristic impedance, and other end, second pair also to be connected with a characteristic impedance, and second pair we have to measure the output. Similarly, in the far end crosstalk, the tone is set in one pair, the level is measured at the other end. So that is the reason it has been called far end crosstalk. Similar way, it is tested for power sum effect of far end crosstalk. So it is pictorially shown here. The disturbing pair is this one, and the adjacent pair is a disturbed pair where far end is being tested. Means output is given here, the input is measured here. Another test is sophrometric level test. This is basically used to measure the interference effect of noise in telephone equipment caused by amplifier, noise, fundamental and harmonic frequency of AC line supplies, as well as by intelligible or unintelligible crosstalks from neighboring lines. Instruments used for measuring this noise is sophrometric. The instrument should be properly calibrated prior to the measurement. Here in sophrometric, the testing pair has to be connected to the input of the sophrometric input, sophrometric terminal, and it should be, the armor of the pair should be earth, and the level will be, sophrometric noise level will be tested here. The typical, the picture of the meter is shown here. This sophrometric, before conducting the sophrometric test, is required to be calibrated here. By pressing the calibration button here, we have to adjust the calibration, calibrate the meter, and after the calibration is over, this has to be filtered to the vintage by pressing the vintage button, and this has to be selected for the impedance of 600 ohms, and different dBm levels are to be selected, that is from 0 to minus 90 degree, 90 dBm we can select. Here both the limbs, testing limbs A and B to be connected and earth to be given, and the level will be displayed. It should not be more than, it should be less than 2 millivolts at any given dBm. The near end and far end crosstalk at 800 Hertz, the value should be, typical value should be minus 60 dB for near end crosstalk, and for far end crosstalk it is minus 65 dB. The next one is insulation test. The aim of this test is to find out the insulation resistance, strength of the insulation of the lines. Every line has a limb, that is L1 and L2, to transmit the signal from source to the destination. If the insulation resistance of the conductor is not within the permissible limit, either with the earth or between them, there will be a loss of signal, and the transmitted signal will be very weak when it reaches the destiny, resulting in improper communication. The insulation test used, measured with Megger is limb 1 to earth, limb 2 to earth. So the Megger earth point will be earth, and the limb 1 is connected to the conductor, and the armor will be connected to the earth, and insulation resistance will be measured. Similarly, For the second conductor, that is limb 2, also to be conducted in the similar way, and between the two limbs also to be measured. The values are to be recorded in the register. The insulation resistance with respect to the earth should not be more than 10 megaohms, and insulation test with adjacent conductors of the quad should be more than 20 megaohms. So these are to be recorded, and the test between the quad 1 to quad 2, quad 1 to quad 3, quad 1 to quad 4, similarly for quad 2 to different quads, all this to be tested for entire 6 quad cable. Standard values of the various tests. The loop resistance for the conductor of 0.9 mm is 56 ohms per loop kilometer. The sofametric noise shall be less than or equal to 2 millivolts. Insulation resistance with 100 volt mega is more than 100 mega ohm per kilometer. If it is used with 500 volts mega, it should be more than 1000 mega ohms per kilometer. The transmission loss in dB per kilometer for the conductor of 0.9 mm is 0.65 unloaded, 0.25 with loaded. The crosstalk measure reading should be at 800 Hertz. Near end crosstalks is better than minus 61 dB. Far end at 800 Hertz shall be better than minus 65 dB. Precautions to be taken while using the quad cable. In designated pair of the wire of the same quad should be used. It should do not use one wire of one quad and another wire of another quad. If any wire of the pair of the quad is broken, then fresh pair of wire should be used. No wire should be parallel for reducing the conductor resistance. So the jointing kits used for quad cable. As per the extent instructions, quad cable jointing kits must be procured from RDSO approved vendors and inspected by RDSO irrespective of the value of the purchase. TSF 1 to 5 joints are used for joining PHF cable, and it is meant for only PHF cable. Never use TSF 1, 2, 3, 4, 5 joining kits to the quad cable. Only RTSF jointing kit shall be used for quad cable, since it is provides with a tinned copper braid which is to be used for earthing at regular intervals. This provides screening effect, nullifies to the induced voltage. Quad cable joint may normally be kept underground, and it is housed in a location box of proper size, avoiding sharp bends as per the local requirement of railways. Whenever joint is kept inside the location box, EC socket shall be fixed on the same location box, and that location box should be painted with black and yellow strip. This is as per the new telecom guidance. Apart from that, in 2019, already headquarters has given a guidelines from our CC that it should be kept in location box and easy to be fixed on the same location box. The screening and armor of the copper cable to be jointed shall be made through with a suitable wire. This is essential to get the specific screening factor in association with its earthing at station. This should be done first to avoid the electric shock due to induction. Copper cable, screen and armor shall be earths with a low value earth less than 1 ohm at station to achieve the specific screening factor. This is the headquarters policy letter issued in 2019. It has been mentioned that elimination of underground joint by providing derivation joints inside the full location box at the end of the length of each 6 quad cable drum, irrespective of whether 1 kilometer spacing between this adjacent EC socket is available or not. EC socket are to be provided on location box itself. Here, a location box has been provided with EC socket and the cable has been fixed on a joint, quad cable joint has been fixed on the wooden plank inside the location box. So different cable failures and precautions to be taken is indicated here. Generally, the first one is manufacturing defect. Test the cable always before laying the cable. Laying of cable at lower depth. Check the depth of the trench before closing the cable trench. Joint failures due to use of substandard expired jointing kits or jointing done by unskilled jointer. Use RDSO approved jointing kits and ensure a skilled person for jointing it. Cable joint burnt due to lightning. Ensure a proper continuity of armor before closing the joint and armor shall be connected to the earth at cable termination. Each resistance shall be earth resistance shall be less than 1 ohm at both ends of the cable termination. Different cause of failures in quad cable. There are some cases that use of quad cable without jelly, the water enters into the joint along with the cable core when there is any cable damage due to crowbar hit in between two joints. Use of PIJ 6 watt cable as per RDSO spec IRS TC 30 2005, where jelly to be provided inside the joint so that the ingress of water can be avoided. Exposing of cable on bridges, culverts and rocky area. This regular cable route inspection shall be done by the section technician, JEs, and strengthen the cable route shall be carried out. Strengthening of the cable route shall be carried out at regular interval as per the telecom action plan. Cable cuts and thefts. Ensure the cable laid within the railway boundary. Avoid the exposing of cable. Implement railway board JPO for earth digging works by engineering department. Update the cable route diagrams. These practices should be scrupulously adopted. The codal life of the quad cable is 20 to 25 years. Whenever this cable failure occurs, there are fault localization is a major hurdle. This is being done in two ways. One is conventional methods and using a cable fault locator. This is most of all knows about how to do it, but it is a very tactful approach required by section supervisors as well as down the line staff. And the conventional methods are people, they find the integrity of the cable is there or not by checking from the station the nearest LC gate phone is working or not, IB phone is working or not, or they will put to the EC point and find out between the EC how the communication is being. So this way, they first localize the section. Of course, this is apart from the checking through multimeter, the loop resistance between the section, how much it is there. This is the decisions mostly SSCs and JEs will be doing and put the section and localize the fault. At the time of commissioning of the cable, the insulation values of the cable should be checked and the value obtained should be more than or not below, shall not be below 100 mega ohms per kilometer with 100 volts megar. This is the expected values for the cable when new cable is being supposed to be laid. If there is a wide disparity between insulation to different conductors, the condition of the cable should be thoroughly checked before permitting it to use. The reading shall be recorded in the register for all the cables. If there is any disparity is too high, the cable should be rejected and one should go for the new cable to different cable to be laid. In the conventional method, as I already told, the last resort is inspection of the cable route by identifying the spot by recent digging. If any recent digging is happened in any of the section, so the TCM and helpers and JEs in the section can identify and target directly to the place where digging is happened. Foot inspection of the entire cable path in the section. If there is any sign indicated by recent digging, the same can be suspected to contain the fault. Excavate the trench and expose the cable. Inspect if any damage on the cable. If there is any damage, operate the cable. So operating the joint nearest to the point of localization. This is a little bit hardsome to do it, but after finding out localizing the section, so the nearest joint one, for example, to be opened and find out whether the fault is in the J2 side or on other side. Similarly, if it is the fault is found in the joint 2, so one has to foot once again to the joint 2 and there expose the cable and localize the fault whether the fault is towards J1 or J3. This is a little cumbersome, laborious work, but if it is to be localized and the cable to be restored back, this method has to be adopted. So the same thing has been explained what I have just explained for the joint 1, joint 2 and joint 3. It is more or like a localization of that faults. So the other one method is cable fault locator. The fault localization by using digital cable fault locator. This is some of the divisions have been using, but experience are different from each division to the division and user to the user. The following types of fault in the cable as mentioned below can be identified using this digital cable fault locator. One is break, that is open circuit, short circuit and induced voltage. So this has been done. The conductor breaks means one limb to one limb or both limb can be break. the positive reflection is shown on the point of break on the meter. So that indicates the cable is broken. Similarly, limb to limb contact faults, a negative reflection is shown at the point of contact. So another one is earth fault, that is limb to sheath. It is very low resistance fault. When pulse is applied between the conductor, the sheath, limb to the sheath, a negative reflection similar to the above is observed. So this is the cable fault locator digital, where you can see the point of where the cable is open, the spike is there, which shows it is open circuit. If it is insulation, low insulation is there, the signal will be in the negative side. The quad cable maintenance. Typical 6 quad cable failures and their causes. Cable burnt at joint due to lightning, and all circuit failed. Armor connectivity in joint was given up. So obviously, when the short circuits or lightning occurs, the entire circuit will get failed, and due to non-connectivity of the armor to earth. Similarly, another case is cable is noisy while train passing in the section, and BPSC circuit is frequently failing. This is also due to improper earthing of the cable armor. Another one is abnormal delay, that is 48 hours in restoration of 6 quad cable fault. Cable was not traceable because cable was laid outside the railway boundary 1 year back, and the colony people constructed the culvert on the cable route about 10 meters. So these are all different faults which are observed. When fault occurs, then only people will realize. Otherwise, it will go unnoticed in many of the time in the section. This is due to the lack of proper inspection of the section. Drainage water was overflowing and spread over the area and got covered with the thick bushes. Staff were not able to walk on the cable route with the cable locator and missed the fault. Cable was found damaged in the culvert. So these are all the regular failures which been reported from the most of the section. The best practice is to have an upgraded integrated cable path diagram, and one should regularly check the cable route tracer, and method of checking should be known to the last front end user, and cable fault locator digital also one should have it in division. So general instruction do's. Quad cable testing of block, BPSC and IB application should be done with a disconnection and jointly with ESM or JE signal. To avoid train detention, ensure proper planning before work and test the circuits after work is completed in consultation with the signaling staff. Before testing the cable, ensure suitable staff available on both ends of the stations. Before testing, check your meters for correct calibration. Isolate the working circuits from the end point and test the cable end to end. Before insulation test, check the earth resistance at the test point. Test results will be misleading if the absence of proper earth. Ensure watering of the earth pit at every visit of your inspection. After testing and reconnecting the cable, ensure functioning of all the circuit with SMR and test room. Don't disconnect block BPSC IV circuit without issuing disconnection memo by authorized staff for testing quad cable. Here, authorized staff means signaling staff, JE or ESL. During the inspections, underground cable installation, when laid strictly in accordance with the recommended practice, will hardly need any maintenance throughout their anticipated span of life of 20 years to 25 years. As far as buried portion of the cable is concerned, no repair are generally possible. No repairs are generally possible except in case where moisture or water has entered the cable and it is detected before it has damaged the insulation. No digging operation by other department shall be carried out close to the cable route without prior notice and prior permission from the telecom sectional engineer, who shall supervise or arrange supervision to ensure necessary precautions to protect the cable from damage are being taken during the work. The latest joint procedures JPO from Railway Board regarding underground undertaking digging works in the vicinity of the railway track and SNT cables alignment shall be followed scrupulously. Each emergency socket provided through quad cable shall be inspected once in every 15 days by a sectional technician, JE, tele for its performance and good shape, and the emergency socket marking on the OHE mass shall be well painted. The maintenance staff should have a provision for vehicle where the men and material can be loaded and comfortably reach the site for early restoration. So this covers the six quad cable or four quad cable maintenance and its testing procedures. So I will be moving further to OFC maintenance. All of us knows that OFC has changed entire communication system in our railways. So it was a day when earlier days copper was used, coaxial was used, UHF link was used, microwave link was used. All these have been gone away after OFC has come up, and because of its higher capacity of bandwidth and its low maintenance and easy to maintain advantages. So, of course, in coming days, coming years, after LTE and IP-MPLS comes, the 6 quad may become redundant. So policy may come up in such a way that everything will switch over to the OFC and its maintenance only. As far as compared to 6 quad, OFC is having a lot of advantage. Its weight is 250 kg in respect of 2000 kg per kilometers of 6 quad. The OFC has size is 9 micrometer, whereas the size of the 6 quad is 0.9 mm. So the cost is also very huge difference. 1 lakh for a 1 kilometer of OFC, whereas 31 lakhs, 3 lakhs for kilometer of 6 quad. The bandwidth is also 100 gigahertz compared to the 2 megahertz of 6 quad. And you know, the protection path will not be there for the 6 quad. And the safety is high in OFC. However, there are some limitations in OFCs. It is difficulty in splicing. Now even this also has many of the technicians and ESMs are been got experience in doing themselves. Hands-on experience are already been having by many of the technicians. And it requires high-skilled staff, precision and costly instruments required to test it. Tapping is difficulty. So costly if underutilized. We may lay a 24 fiber, but we may use only 1 or 2 fibers. So underutilizations is one of the drawback. And special interface equipment required for block working. And optical to electrical, electrical to optical conversion is one of the limitations of the OFC. So with respect to the wavelength, attenuation to the wavelength of the OFC, there are 3 windows. One at 800 nanometers and another is 1300, and third window is on 1500. So all of us, you know that we are using 1310 window as far as possible and 1550 also in our railways. So 850 window, first window, we are mostly not using in our railway. The losses in OFC is due to absorption loss, due to impurity, absorption loss, and scattering and radioactive losses, that is microscopic band and macroscopic bands. So the factor causing the light absorptions are due to impurities, presence of ions in silica, so residual materials within the fibers and inner cladding. The absorption of the optical energy by tiny impurities in the fibers such as iron, copper and cobalt are cause of factors in OFC. The scattering of light due to molecular level irregularities in physical construction of the fibers, a well-known form of relay scattering, and relay scattering is caused by metal ions in the silica matrix. Relay scattering limits the use of wavelength below 800 nanometers, shorter wavelengths. Here it has been shown that the loss, the absorption loss shown in the pink color inside the OFC, and the scattering loss is shown in the brown color. Micro bending loss is caused by micro deformation of the fiber axis at the time of manufacturing which leads to failures in achieving the total internal reflection. You know, most of us already know that OFC working in total internal reflection, this micro bending loss will cause the deformation in the fiber axis during the manufacturing, which leads to failures in the achieving the internal reflection condition. Similarly, micro bending are all small scales along the fiber axis and amplitudes of which are one of the order of microns. These distortion can cause light to leak out of the fiber. Due to thermal expansion and variation due to load exerted on the glass cause the micro bends. Coating material is selected by the manufacturer to minimize the loss due to micro bending, and the linear thermal expansion coefficient of the coating material shall be compatible with that of the fibers. The reasons are too many, but micro bending and this macro bending will affect the quality of the OFC. Here in macro bending, losses caused by bending of the entire fiber axis, the bending radius shall not be sharper than the 30D, whereas D is the diameter of the cable, that is approximately around 20 mm. So similarly, one single bend sharper than 30D can cause a loss of 0.5 dB. If bending is even sharper, the fiber may break. Similarly, here, unlike in quad cable, OFC also to be tested before laying the cable, testing after the cable is laid, and routine tests are to be conducted. And as all of us, you know that the OFC is laid inside the duct, and duct integrity test also to be conducted, and drum test also to be conducted. Here the duct integrity test, any work is carried out by any agency, before blowing of the cable, the integrity test has to be mandatorily tested. Actually, a duct shall be tested for duct integrity. The sole purpose of the duct integrity is testing to prove that the installed ducts are ready for blowing of cable without any hindrance from the manhole to other. Tightness test to be conducted before blowing of the cable. The airtight test is done by pressurizing 2 to 3 kilometers duct stretch at a time. At one end of the duct will be closed and compressed air of 5 to 6 kg centimeters pressure is sent from other end. At about 5 kg per centimeter square pressure, the inlet of the compressed air will be closed. Fall in pressure should not be more than 50% in 1 hour. Here in this case, it shall not be 3 kg to 2.5 kg after 1 hour of filling the airtight pressurized air in the duct. Drum testing. Before laying every cable drum to be tested, normally drum length is about 3 kilometers. As you know, drum number, length of the cable, running meters to be noted. All fibers to be tested with OTDR and traces to be stored. If any event or break observed, avoid laying and or reject the cable. Testing of fiber after laying of OFC is also a mandatory. All terminated fibers to be tested with OTDRs and traces to be stored. Power measurement to be done for every fiber with a laser source meter and power meter. Average loss to be less than 0.2 dB per kilometer for 1550 nanometers and 0.335 dB per kilometers at 1310 nanometers. These are the different types of connectors used in OFC. So LC connector, SC connectors, ST connectors, which are being used regularly at the field. And for academic interest, different types of connectors with their insertion, loss, repeatabilities, and the fiber types and applications have been indicated here. Further, this is the FDMS, Fiber Distribution Management System, provided in the OFC HUD. And the pigtail connections at the back of the FDMS, typical patch cord image, and test measurements. In test measurement, power meter is being very commonly used for testing any cable. Power meter by itself can be used for the measuring the source power. Here, a source will be connected to the cable to be tested, and the power meter will be connected on the other end to check the value of the power. Here, this is OTDR, which is the important tool for testing of any optical fiber. Optical time domain reflectometer. The OTDR is useful for testing the integrity of the fiber cable. The aim of this instrument is to detect, locate, and measure event at any location in the fiber links. The main benefit of the OTDR is that it can fully test a fiber from one end. OTDR meter is most effective when testing long cable, more than approximately 250 meters. Produce a graphical display of fiber status with different events. OTDR measures data can be stored for documentation in the form of soft and hard copies for the future reference. So OTDR can also measure the cable breaks with almost exact distance. Measures the slice and connector loss. Measures the transmission loss. Gives the length of the cable. All this also can be measured through OTDR. The basic principle, almost all of you know that it works on backscattering principle. It detects small reflected signal in the response to the injected large signal. There are two different types of reflections. One is relay backscattering and Fresnel reflections. Here it has been indicated the OFC attenuation has been indicated here over the distance. Here it is relay scattering portion is being indicated. Similarly, Fresnel reflections at connector pair, fusion, connector pairs and mechanical pair splicing are being indicated, shown in this picture. So the dead zone. So dead zone, the length of the fiber which is not fully characterized during the recovery period is termed as dead zone. This dead zone length depends upon the incident pulse signal. Stronger the pulse, more the dead zone. To overcome these dead zone problems, a dummy or spare cable length of approximately 100 meters will be used. So the dead zone portion is being indicated here, where the measurement will not be taken. This 100 meters dummy cable will be connected. After that, only the actual testing cable will be connected and measure the values. This is a sample information of OTDR trace. So the attenuation over the OFC is being indicated in this. The slope of trace shows fiber attenuation coefficient. So here the connector is being connected. The loss due to connector is being indicated over here. This is the splice loss connecting the two cables. This has been indicated here. So the information of stresses can be identified through this. So same thing has been explained here. Study of OTDR traces. The slope of the fiber trace shows the attenuation coefficient of the fiber, and it's calibrated in dB per kilometer by the OTDR. Connectors and splices are called events in the OTDR jargon. Both should show as loss, but connectors and mechanical splicing will also show a reflective peak. The height of that peak will indicate the amount of reflection at that event. Sometimes the loss of good fusion splice will be too small to be seen by the OTDR. That's good for the system, but can be confusing to the operator. It is very important to know that the length of the all fibers in the network, so you can know where to look for events and won't get confused when usual events shows. As far as the OFC visual fault locators are in red light laser will be used. They visually locate fault up to 5 kilometers. By sending visual light, the operator can easily see the break and important bends in the fiber as the light escapes out of it. This function make them useful for continuity test of the patch cord, jumpers, and short section of fibers. These are the pictures of the visual fault locators, that is pen-shaped VFL and handheld VFL. So as per the telecom manual, the maintenance schedule for the fiber optics system is the power supply equipment, maintenance of the battery, a telecom technician monthly, section supervisor quarterly, and supervisors in charge are half yearly to be done. So the power supply portion is almost similar for most of the technician, supervisors, and sectional supervisors and supervisor in charge. So there are some important checks are there which requires maintenance of the pigtail fiber distribution frames, that is quarterly by supervisors and yearly by supervisor in charge. OTDR measurements for the spare cables, spare fibers, it is quarterly by sectional supervisors and supervisors in charge yearly. This is for spare fibers. And cable route, integrity of the cable monthly by technician, protective works on bridge and culvert monthly by technician, quarterly by supervisors and in charge by yearly. So cable route markers, earth of the sheath of the cable, these are all monthly, quarterly and yearly by technician, section supervisors and supervisor in charge. See, this periodical lineup, that is OTDR measurement on all fibers, trans, receive, optical fiber, optical power loss, error performance measurement has to be done yearly once, including the spare and working. So, you know that there is a JPO is being given by railway board for undertaking digging works in the vicinity of signal, telecom and electrical cables. So in this regard, it is issued in 2013, and among this, the most important one is the point which is 14, which I'll just repeat it. In case damage caused by OFC bar quad cable during the execution of the work, the contractor is liable to pay the penalty for damaging the cable. Penalty shall be levied in case of the following 4 points. That is, one is detailed cable route plan as per clause C1 not provided by concerned department, or cable is not protected as per laid down procedures. See, it is a detailed cable route plan has to be updated every time. It should be given properly. Otherwise, we will lose, leaving the penalty. Similarly, second one, the alignment of the cable does not tally with the information provided provided to the contractor. Third one is the cable depth is found to be less than 800 millimeters from normal ground level. So the depth is properly to be checked, ensured. And fourth one is no representative of SNT department or railtail staff was available at the site guarding the cable on fixed predetermined date and time. If it is not adhered, so that we will not have a chance to levy penalty on the contractor or the agency who has carried out the work. Similarly, the fifth point is the penalty to be imposed for the damage to the cable is for the quad cable 1 lakh, for OFC 1.25 lakhs. For both OFC and quad cable laid in the same trench is 1.5 lakhs. So these are all the JPO guidelines. These debits in this regard shall be raised on the department undertaking the work, who shall in turn levy the penalty on the defaulting contractor. The SNT department shall raise the debit in case of damage of OFC or quad or signaling cable, and electrical department will raise the debit in case of the damage to electrical cable. Another 16th point indicates the railway will not lodge FIR with RPF in case of work being executed by authorized contractor of railway who have been duly permitted to execute the work in accordance with the JPO. Joint note by the supervisors of the concerned department shall be prepared, and the responsibility of the cable cut should be decided without involving RPF. The joint note deciding the fact whether the contractor should be penalized shall be completed in the day time from the occurrence of the cable cut. In all cases, when the cable is cut by the agency that was not permitted to execute any work, FIR should be lodged with RPF. So these are all the most important points of the JPO, which all of us has to adhere to. And another most important thing is the recent past, a CPMS application is being developed by the Vijayawada division, that is Cable Protection Management System. A web Android based application is developed by the Vijayawada division for carrying out earthworks. This is also been already directivity is given by the headquarters by PC History sir to all the division to implement, and most of the divisions is already in the work is taken up, already implemented in other divisions also. Here in this, it is executing agency unit will apply for the earthwork to concern signal, SSC signal and telecom section kilometer wise. Concerned SSC can accept the request by nominating the staff with their designation and phone numbers so that executing agency can directly contact the staff. Or concerned SSC reject the request with a proper reason. Maybe those days may not be conducive for the carrying out the work, or he may reject it because with a proper reason. The concerned SSC can even ask the contact them if in case of any doubts. So they can resolve among themselves by consulting each other, and they may take up the work with a mutually convenient time. Real-time data transparency between the executing agency and supervisors is achieved through this, and dedicated record and maintenance, dedicated record and maintained with the transparency of CPMS work, retrieval of data made available on cloud 24/7 on fingertips. So this application is being useful for all of us, and it is been given directed by the headquarters to utilize extensively. So with this, I will concluding my presentations. If any questions are there, or any participant can ask. So I saw one question from ASTE Vikarabad. As per latest instruction received, the EC socket should be fixed separately and not on location box. As the location box is placed far from track center, kindly clarify this regard. So EC sockets, it is already been given directivity that the quad cable joint may normally be kept underground, and it may be housed inside the location box of a proper size, avoiding sharp bends as per the local requirement of the railways. The EC socket should be fixed on the location box itself, And that location box should be painted in a black and yellow colors. This is the guidelines and as per the telecom manual, new telecom manual. So just a minute. Only one question. So another question is painting of location box with EC sockets to be clear. In our section, new RE works painted with the black and white strips. Yeah, that this is as per the new telecom manual, it is supposed to be painted with the black and yellow strips only. So you can show that the page number 74 of the telecom manual, this may be shown to the RE officials and ensure that it is been maintained as per the telecom manual. So they have to correct themselves. So. I hope any other questions or anybody? Another question is there, in case of any cable cut, OFC or 6 quad cable, as per the JPO 2013 joint report prepared by the section SSC, SNT and other concerned department SSC, in this case, concerned contractor is not carried out work as per the JPO or not following JPO. If cable depth found less than 0.8 meters, in this case, penalty imposed or not, please clarify. I told already in the JPO 14, it is clearly told the contractor, see, the penalty cannot be levied if it is not as per the JPO. So it is our open line section's responsibility that it should be laid that as per the detailed cable plan and alignment should be given. Yeah, tell me. Tell me, sir. I'll just show you once again the JPO. See, in case damage is caused to OFC bar quad cable during execution of the work, the contractor is liable to pay a penalty for damaging the cable. Penalty shall not be levied in case of the following 4 points. That is, first is detailed cable route plan as per the clause C1. It is C1 is shown in the on the starting of the JPO, not provided by the concerned department. If it is our SNT, we have to provide the cable route plan properly, or cable is not protected as per the laid down procedures. Means if it is at the depth of 1 meter, okay, we can, there should be a brick If it is less than 8.8 meters, it should be protected with the RCC or duct, or cementing should be there, concreting should be there. Otherwise, the penalty will not be possible to impose. The alignment of the cable does not tally with the information provided by the contractor. So you have to give the proper indication to the executing authority that my alignment is so and so distance away from the track, and the cable depth is found to be less than 800 mm for normal ground level, and no representative of SNT department or Railtel was available at the site regarding the cable, regarding to the site at the guarding the cable on the fixed predetermined date and time. So you call them and you are not available, it is a problematic for us to impose the penalty. I hope I answered your question. And lastly, I will just shares few pictures. These are all the good practice. So before laying the cable, the trench can be measured with a stick, which can indicate properly the depth of the 1 meter indication, 1.2 meter indication, and 0.8 meters. A strip has been pasted on that stick. So one person can just walk around on the trench so that we can easily make out that the depth of the trench is 1 meter or less than 1 meter. And the adjacent one is the bridge where the quad cable is been laid through a GI pipe with a proper clamping arrangements. You know, when executing agency is unwinding the cables, it should be used with the proper jacks. Here you can see a cable drum is been unwinded using a jack. Another one here on the bridge, there is a exposure of the cable was there, so the concreting was properly done and covered so that the theft cannot be made in the future by any miscreants. Here in this case, the trench, it's a rocky area. The agency could not go more than 1 meter. So a concreting has been done by 1 feet depth above the rocky area. On the left side, you can see horizontal boring. Cable is been taken below the track. On the right side, EC termination with a proper insulated sleeves connecting to the EC point. So this is some of the bad practice. The quality of the RCC pipe is not good. One should measure, one should test before the utilization of the RCC pipe. A sample test has to be done. Similarly, this is a cable marker, which is also was not a good quality one. And when a marking was given, in this case, a trenching was done at the place where near to the drainage. Due to that, before laying the cable, the water got into the trench, and this sort of marking shall not be given to the executing agency. Here, the cable is being taken exactly 45 degree with a 45-degree bend. So this is not the correct way. It should be taken in a proper curvature. And here on the right side, the earth was laid. The GI pipe was fixed with a loose soil, and when it has heavy rain has come, it got collapsed. The all mud got collapsed and the pipe is exposed. So one more question has come up. So it is posed by ASTE Nallur. Okay. As per the latest policy, all quad cable joints are provided inside the location box. Then what is the necessity of quad cable joint inside the location box inside? Location box instead, we can go for WAGO or ARA termination. Which will help localization. This is, see, one is, it is as per the telecom manual. These are all trial tested. The WAGO terminal and other putting into the any place, it is not a practice which has been directed to us. In my opinion, it is not correct. But as per the telecom manual, only one has to lay, and it should be fixed in the inside the location box with a jointing arrangement only. So my feeling is that somebody will meddle into that when some train is going at some incident may happen. So sometimes the WAGO has got a disconnection and we are reconnecting method facilities are been there in the termination. It is my opinion. So sometimes by mistake to demonstrate to somebody without the consent of the station master. So sometimes by mistake, technician or anybody may demonstrate to somebody else, or he may check, or sometimes to clean it, he may do it. So this sort of things may affect the train movement. It has been decided by the higher ups before finalizing the telecom manual. So it is better to practice as per the telecom manual. Thank you, sir. I hope I have answered almost all questions. And I conclude with this. I thank you each and everyone. And also I thank my CC sir, PCST sir and CC sir and CST Vittal sir and Deputy CSTs and all my colleagues who have supported me